lesson, right? You guys had a chance to kind of try it out on your own, try and use your own brains to like expand your brain a little bit, right? Extend your thinking, like, can I do this without the lesson, right? It's like, it's a way for you guys to kind of grow your knowledge a little bit and being able to stretch yourself, all that stuff. So now I'm going to go back and I'm going to show you exactly what it is we're doing today, okay? So then you can take what you learned on your own and then what I'm teaching you right now and kind of put that together. And hopefully you'll have a good understanding of it at the end of the lesson, okay? So lesson 2, we're going to estimate multi-digit products, okay? Product is an answer to a what problem?
Multiplication.
Multiplication, good. I want to hear it again, but with confidence. A product is an answer to a what problem?
Multiplication.
Multiplication, good. Okay, so we're going to estimate. So when it says estimate, are we going to find exact answers today?
No.
No, okay? Anytime we see the word estimate or estimate, right? Estimate is the noun, estimate is the verb, okay? So we're going to estimate. I want you to think of the word about, okay? About means that it's not exactly this, but it's about this and that, right? And then remember, I like how Drew was like, wait, why are those equal signs squiggly, right? Remember, squiggly means about, okay? Everybody go like this and show me about, and say about. About, right? You also can say when you see this, right, you can be like, it's about this, right? Like that's what I want going through your brain as soon as you see estimate, okay? So when we estimate multi-digit products, we're finding the about answer. It's not the exact answer, but the about answer, okay? And we're going to do that by rounding factors, okay? Here's the important bit. Factors, and I actually want you to write this in your notebook. Factors are the parts of a multiplication. Actually, we're gonna do a multiplication symbol sentence, and I'll move out of your way in just a second. But if we have 4 times 3 equals 12, 4 and 3 are the factors. Okay. 4 and 3 are the factors. Does that make sense?
Yes.
Okay. Olivia? Okay. Drew, can you like scoot your desk back a little bit? Is that, and then Luke, are you still able to see?
No.
Okay.
Why don't you like move forward more?
Like, yeah, Luke, that's fine. You wanna, like,
Not fine.
is that good?
I'll be an island.
Okay, sounds good.
I want
Is
to
that
be
okay
an
with you?
island
Does that help?
too.
Alright. Yeah, I'm sorry, y'all. I will figure out a way to make it better. Okay? Yes.
I am an island. Not yourself. For like Japanese origin, you have to think of it as an island. Because I already knew that it was estimated.
Yeah.
That was like that for a while.
Yeah. Same thing. Same thing. Like estimate and about are communicating the same thing. So if your brain just goes straight to estimate, that's fine. That's totally fine. But yeah, I also I do want you guys to write the word estimate and then that it means about. Okay, so anytime we see estimate, it means about. So go ahead and write that in your notebook as well. I'll give you a couple seconds. Okay. Thank you for being patient, you guys. You're doing a great job. Yes, then.
Just like estimate / about kind of work.
Whatever it means to you. Like whatever is gonna make the most sense to you, that's what you're doing. Alright. Okay, so to reiterate, we're going to estimate multi-digit products. So estimate the answers to multi-digit multiplication problems by rounding the factors, okay, so the parts of a multiplication sentence, to a basic fact, so meaning rounding it to the nearest 100 or nearest 10 or whatever it is, and then using place value patterns. So again, having that understanding of place value is really important. Knowing that when we multiply something, it moves to the left on a place value chart, it gets bigger, right? That sort of thing, okay? Yes, Olivia. We're going to talk about that. But yeah, good question. And if I don't answer that question by the end, can you ask it again? And that way I'll make sure to get it. All right, awesome, friends. So we're going to just bounce forward really quick, actually, though. I want to make sure that we're still understanding rounding, though, okay? Because this lesson will be hard if we don't have a total grasp on rounding, right? So 48,625. If I was going to round to the nearest 10,000s, I need to find which digit is in the 10,000s place, okay? So I look at this and I know that 4 is in the 10,000s place, okay? So 4 is in the 10,000s place, and I look to the digit to the right, okay? I look to the digit to the right, and it's an 8, okay? And remember, if it's 5 or above, it tells this number to go up. If it's 4 and below, it tells this number to stay the same. It doesn't go down to 3, but it stays the same, right? So this number 8, is it going to tell the 4 to go up or stay the same? Go.
Up.
Up, good. So that 4 changes to a 5, and then everything after it turns to a what?
0.
0. Beautiful job, my friends. Okay, and that's it. That's rounding to the nearest 10,000. Okay? So then again, we're just going to go through each of these for this number, and then we're going to move on, okay? So rounding to the nearest thousands, I need to see which number is in the thousands place. That's my 8, okay? I look to the digit to the right. What digit is to the right?
6.
6, good. So that 6, is it going to tell the 8 to bump up or stay the same?
Up.
Bump up, good. So everything before stays the same, right? So the 4 has to still be there, okay? Then the 8 bumps up to 9, okay? And everything after the digit that we're rounding turns to what?
0.
0, okay? So rounding to the nearest 1,000 is 49,000, okay? Are we good so far? Do we have like clarifying questions on this? We good? I'm bleeding, my friends. I'm sorry. I don't know where that came from, but good question.
It's a comment.
Go ahead.
I like to think of it, you know how there's like 48,000?
Mm-hmm.
I like to think of it like if it's over 5,000, it's kind of like gas, and the force like a car. It has to go up a ramp and jump a ton of cars, and if it jumps enough cars, it can't step by. And it has to have more than 5, whatever the 5 is in that.
Okay. Nice. I like it. Yeah, and then I remembered just now too, like Oliver's example of the guy across the street, right? Like, if it's 5 or more, like you should keep going across the street. If it's 4 and below, should go back, right? So yeah, awesome. Lily.
I was looking at the chart thingy,
Yeah.
and I was like, wait, couldn't you round one? No, I said do that. And then I was like, wait, could you round like tenths and hundredths?
We already did that, right? We rounded decimals last module, so we did do that.
I mean, like, could you round them with whole numbers, like just
Not sure exactly what you mean.
like, can you round actual decimals?
Yeah, we did that. We rounded like so if I had 4.27, do you mean like rounding these guys?
Yeah, but I mean, like, not rounding the 4 and rounding like the 2.
Yeah, we did that. Rounding to the nearest 10th, right? So 4, the 7 tells it to do what? Yeah, go up, right? So rounding to the nearest 10th, it's 4.3. We did that last month.
I was like,
Yeah, we did, and it was on your test too. So yeah, all right, cool. So rounding to the nearest hundreds, same deal. I find what's in the hundreds place. I look to the right, okay? So my 6 is in the hundreds place. In the tens place, I have a 2. Is that 2 going to tell the 6 to bump up or stay the same?
Stay the same.
Stay the same. Good. So everything before stays the same. Okay? And then everything after turns to a 0. So rounding to the nearest hundreds, it's a 6. Okay? Last but not least, rounding to the nearest tens. Okay? There's a 2 in the tens place, 5 in the ones. Okay? Does the 5 tell the 2 to go up or stay the same?
Up.
Up. Awesome. So everything is the same except for the 2 changes to a 3, and then it's a 0. Okay? Henry, go ahead. Any questions about rounding? Because you basically gotta know how to do this to do today's lesson. Okay? All right. Cool. So let's get into it. All right, my friends. When everybody's here, how many people do we have in this class? Don't say it. Think about it. We have 24 cubbies, but remember some are missing. So think about how many we have. See if you can get it. Are you ready?
Yeah.
Okay. How many students do we have? Go.
24.
So close. 21. 21.
Today we have
Today we have how many?
18.
Good. Well, we did, and then Jackson came. So we're just missing 2 today. Missing Mika and Charlotte.
Oh,
so minus 2. 19. Okay. Yeah, she's on a trip this week, so she's not here. But anyway, so hi Charlie, good to see you. We're talking about your trip. Hope you're having fun. Yes, Donnie.
We used to have 24, but since Alexa and Sophia didn't come, it was 22, and then when Savannah left, it was 21.
Yes.
So the total number of students is 21. We also have the same number as the 5th graders last year.
We had 19 in 5th grade.
Oh.
So today we have the same number, right? All right. Beautiful. Do all classes at this school have exactly this many students? No, they do not. For example, there are 9 students in 8th grade, right?
What?
So, no, we do not have the same in every
There's
class.
9 in
Okay.
7th grade.
Number 3. This school has so many classes, but I'm not sure exactly how many students are in each class. What can I do to find the number that is close to the actual number of students at our school? So I'm going to pause really quick. So we're not going to count preschool right now. We're just going to do like kindergarten through 8th grade. So
I'm sorry,
kinder, first, second, third, fourth, fifth, sixth, seventh, 8th. Okay. How many classes do we have at this school? 9, not including preschool, pre-K, right? So 9. This school has 9 classes. Okay. And I want to figure out about how many students there are at the school in general, like at the school total, right? So I have to think about how I can find the number that is close to the actual number of students in the school. So we're finding about how many students are here at the school, okay? So we had, let's see what's next actually. So what could I want you to take like 20 seconds in your group, and you're gonna think about what could we do with 21 and 9 to get a good estimate of how many kids are at this school. You're talking to your group. Ready, go.
What's 20 times 9? 20 times 10. 20 times 10?
20 times 10.
Exactly how many kids are at the school? 200. Actually, in real life, I think it's like 100. It's from 100. I think it's like 100. What? It used to be. It used to be 200.
Okay, 5, 4, 3, 2, 1, 0. All right. So Luke said, I just like what he said. He was like, okay, so what's 21 times 9? No, wait. What's 20 times 10? So Luke, what did you do to change to?
I rounded to the nearest 10.
Awesome. Yep.
And
So
then I just added the 0.
good. So we kind of in our heads we should start with 21 times 9. Okay, like if there's about 21 kids, per class, right? If we're basing it off of our class, right? Okay, 21 times 9 classes. But I don't know about you, I don't know how to solve 21 times 9 in my head very quickly, okay? So what I can do is I can round those, right? So I can round 20 to the nearest 10. So Luke, 20 to the nearest 10 is what?
20.
20, okay? Good. And then, Danae, what's 9 to the nearest 10?
10.
10, awesome. So isn't that a little bit easier to multiply in our heads, right? What's 20 times 1, friends? Go. 20. And then since we're multiplying by 10, we add in that other 0. So there's about 200 kids at this school, okay? So we see kind of how we found that. Okay, Brady?
I just rounded 21 down to 20, and then I took away that 0 for now, and then I did 9 times 2, and then I got 8.
Good, okay.
18, then I did 0.
And 0. So 180. Good. So that could even get you a little bit more of an exact estimate, right? That's a little closer. Yeah, Brady?
But also, like this, it's pretty, but, 9 times 1 get 9, 9 times 2 get, 18, so that's, 18 plus.
Good.
And then, so then it'd be 180.
Good, yeah. And so that is true, but we're working a little bit more with rounding today. Like, think of the problem set. Like, we, because the numbers were a bit bigger, right?
Yeah.
So, but that's a very good point. Like, you're kind of taking what we did yesterday and applying that. So that's really cool. That's great. Melina.
In 3rd grade, we had exact 200 kids.
Nice. Okay. In 3rd grade, that's a lot.
No,
Just kidding.
For the whole school.
Whole school. Wow. Dang. Cool.
And we got that earning in 3rd
Emma,
grade.
go. Eddie.
How many people are at this school?
It's like 182 or something like that.
Yeah, actually, if you put 20
So
on
close.
the
Yeah.
line, it's
So
really
then,
close.
hold on. I want to bring in what Brady just said. Okay. So I went ahead of what this is saying. So I'm just gonna put that back up. Okay. So Brady said, so Miss Witt did 20 times 10, right? I put them in multiples of 10 to kind of round a little bit more easily, right? Can you guys okay. So I put them in multiples of 10 to be able to round a little more easily, like quickly. However, with this particular problem, you guys are totally capable of multiplying 21 or 20 times 9 in your head. So it's like 100. So Brady said he did 20 times 9. Okay. So you don't necessarily have to round the 9 to 10. You can, but you don't have to, right? So 20 times 9, we can do 9 times 2, which is 18. And then make sure not to forget that 0, right? So for Brady's estimate, we could do about 180, right? Which I know we worked on this last year as a class for the most part, right? Which do you think is more accurate, 180 or 200?
180.
180. It's a bit more accurate, right? So that's kind of what we will work with a little bit today too, is which one is more reasonable, which one is more accurate, right? Because we want to get as close to that actual number as possible, even without knowing the actual number, okay? Any questions on this concept of rounding the factors, multiplying? Yeah, Henry.
So if we were trying to get to the most accurate,
Yeah.
so would we round to the nearest 1?
Good question. So we could, with this problem specifically, but remember on the problem set that we just did, those numbers are really big.
Yeah.
So it's going to be a little harder to get to the exact answer per se. So you're going to have a little bit more numbers like this, multiples of 10 on your homework and stuff like that. But in real life, this is a little more accurate, right? So rounding to you don't have to round 9 to 10. You can leave 9 at where it's at. But today you'll do a little bit more of 20 times 10 or 200 times 30, that sort of stuff. It's kind of what we'll do today. All right? So then here's a little more familiar based on the problem set, right? So we're gonna just do a couple of these, and then I think you guys will be ready to move on, okay? So 456 times 42. This is a factor right here. This is a factor right here, and we need to find the product, right? The estimated product. That's why this technically should be a squiggly line, Okay. We're going to find the answer that's about the answer to that, right? So then we have to ask ourselves, it's kind of what Olivia was asking earlier. She's like, how do I know what to round it to, right? Personally, and this is where you guys have to kind of use your own brain a little bit, okay? You have to round it to the place value, right? Either pretty much in this case, the hundreds or the tens. That's going to make it easiest for you to round, okay? So remember from last year, or even like when we were doing rounding decimals, remember I told you that when we're estimating, we might not all have the same answer, and that's okay, all right? As long as we're in the same ballpark, that's all right. Because everybody looks at rounding a little differently. And so you're going to round to the place value that's going to be easiest for you to multiply, okay? So for some of you, that might be rounding this to 500. Oh. Right? 500 times 40, right? That might be easiest for some of you. Some of you might be able to do 460 times 40. Right? And bottom line, we'll all still be in the same ballpark. So it is okay. So basically, rule of thumb is whatever's going to be easiest for you to multiply is what you're going to shoot for. Okay? Olivia.
To multiply
Kind of. Mostly because we haven't worked a lot with the standard algorithm, right? So the point of yesterday's lesson and today is to be able to learn some multiplication strategies to help you multiply more efficiently, which sometimes means in your head, right?
and another thing, how do you get 40 out of 43?
So 42, like are you asking how I got 40? I rounded 42 to the nearest 10, so 42 would round down to 40. That's the near, right? If we were to like underline, look to the right, 2 tells 4 to stay the same, so 40.
Stay put 2. Stay put 4.
4, yes, yeah. All right, Henry.
And also, when I said about rounding to the nearest 1, I wouldn't be able to do that unless there was a decimal, because it's always just going to be the same.
That's true, yeah, it would just stay the same. Yeah, that's a good point. That's a really good point. Last thing, Brady, and then we gotta move on. Go ahead.
So would the answer be 264?
We're not there yet. But so Miss Witt personally, I would round more easily by doing 500 times 40. Okay, so that's what I would choose to round to. Okay, but again, if something is going to work a little more easily for you, do that. Okay. Personally, though, I can look at this and multiply it in my head, and so that makes it a little more efficient, a little more easy, right? So 5 times 4 is going to give me 20, okay? And then knowing my place value understanding, knowing the y, okay, then I know that I can put in my zeros afterwards, okay? So my answer would be somewhere around like 20,000, okay? But then, Brady, what did you round to get a different answer?
I did 460 and 40.
And 40?
Yeah.
All right, cool. So then, what did you get for 46 times 4? About?
Oh, wait. 46. Oh, 46 times 4, I got 264.
Okay, awesome. So 264, and then putting your zeros in after. So yeah, 26,400. So then here's the thing. I see a lot of people like writing things that they don't. You're not really writing anything right now. So just go ahead and pause on that, okay? So here's what I'm talking about, where we could have different answers, but I would say that Brady and I are in the same ballpark. Like I would put this in the same, like they're pretty close together in some way, right? 20,000 or 26,000, they're pretty much there, right? But if I had gotten like 470,000, maybe that's not as accurate, right? It's probably not a very good estimate for this answer, okay? Down there you go, Brady.
I just don't get it, because like 500 is bigger than 460.
Mm-hmm.
So how did the 460 get more than 500?
Maybe we have
It's
Correct that. Let's
because
see.
what? Yeah, that makes no sense. Wouldn't it be 132 plus
Oh.
130? Yeah.
So 46 times 4. So sorry, I didn't check your math. But if we're doing like we're multiplying like the numbers that aren't multiples of 10, right? 46 times 4. I got 184. So it should be 184.
Yeah, that made no sense. Like,
Yeah.
500 and 400.
All right. So sorry, it should be 18,400. That was my bad. I should have checked that.
Yeah, I did 4 times 4 and then 4 times 4.
Okay, I see. But remember that it's like the 4 right here is a 40, not a 4.
Yeah, that's
So, yeah. But so to recap what just happened, okay? Brady told me his answer, and I didn't like think about the multiplying part. So really though, this is important because I do give you guys permission to go off to the side and do standard algorithm for like things like this, right? What I don't want for you to do today is multiplying standard algorithm like this. Like this isn't what I'm looking for. I'm looking for like still trying to, I guess kind of, Olivia said like, so doing it in your head. I guess kind of still doing it in your head, but I give you permission to do like this part of standard algorithm and then adding in the zeros after to kind of help with that place value understanding a little bit. Because we will start standard algorithm tomorrow. So like we don't need to get to that until tomorrow. Today you guys are still just learning strategies to understand multiplication even better. Okay? So here's what I want you to do. Let's see. We're gonna alright. And then here we're talking about like, okay, taking the same digits, but this one is 10 times bigger than the last one, right? So maybe rounding to the nearest 1,000 would be a bit better for me in this case, right? So even if the number gets bigger, right, you still have to think about what's going to be the easiest way for you to multiply, right? So maybe still this is 5,000, and then maybe this is 400, right? So as you can see, I shoot more towards the multiples of 10, but that's like up to you, right? Brady, then Henry.
Maybe on the top one, the 456, that one.
Mhm.
Yeah. If you rounded that like 1,000 to 456, once you get like 0, so then your whole answer would be 0.
I meant this one when I was saying that, like rounding to the nearest 1,000. I meant this one.
But still, if you did do it for the top one, then it'd be 0.
But it wouldn't really make sense to round this to the nearest 1,000, right? Because it would be, the nearest 1,000 would be, I guess technically 0. So then, but that wouldn't be a very accurate estimate, right? So, Henry?
For number 2,
Mm-hmm.
it would be kind of, you wouldn't really do anything for the, like if you rounded to the nearest 10 on that one, it'd still be the same answer for the first one. Like it'd still be 4,560, and then times 40. Because if you rounded to the nearest 10.
If we did nearest 10, but it did change value though, right? When we add the 0. But yes, you're right. It would still, if we're running to the nearest 10, but it maybe wouldn't be an accurate estimate though, because we still have like, it's 10 times bigger than the last problem. You know what I'm trying to say? A little bit? Like, I would say that rounding to the nearest 10 wouldn't be the best estimate for this one because we have like thousands going on here, So maybe nearest 100, but that's why I think like going to the nearest 1,000 would be best, just because it's, But sometimes it's not, it just depends. It really does just depend.
And you could do, so, like basically on all 3 of those,
Mm-hmm.
you could do like, on the first one, round to the nearest 10. Or, I could round to the nearest 10. On the second one, you could do ceremony, but also you could do 100 again.
Yes. Yeah, that's a good way to put it. Okay, I really would like you guys to try some of these with me, just so we're all on the same page, because we weren't really able to do that much yesterday, just because it was a bit confusing, right? So, I actually go ahead and take the problem set out. Take the problem set out again. And we're going to go back and look at some of the ones that you tried, okay? Yeah, it doesn't require talking. I would really love Brooks and Diego to find their problem set and take it out, because that was the direction. All right, when you have the problem set out and you have a pencil, go ahead and give me a thumbs up on your desk so I know you are good. Just so your arm doesn't get tired. You just put it on your desk. Alright, we've only got about 5 minutes to do this, so we gotta move a little fast, okay? How's everybody doing? Meh? Okay. I know we got into big conversation there, but bottom line with today's lesson, you're gonna round the factors to whatever place value you think will be best, okay? Guys, we don't have to focus on that, just pick it up, it's good, okay? So, backtracking, making sure you're listening. Bottom line with this lesson, we're rounding the factors to the place value that you think is going to be best. Okay? We might all have different answers, that's okay. And then you're going to multiply your rounded factors to get an estimate. That's it. Okay? That's pretty much it, all we're doing today. Okay? So looking back at the ones that you tried without me, right? 597, I personally would round it to the nearest 100, right? So 597 rounded to the nearest 100 would be what? Go.
600.
600. Okay? Does everybody understand how I got 600 when I rounded? Right? Because even if we rounded to the nearest 10, right, it would pretty much bump up to 600. Okay? So then I can multiply my second factor, which is 52. It would make the most sense to round that guy to the nearest 10, right? So 52 rounded to the nearest 10, go. 50. Okay. So then from there, if I do 600 times 50, I can do 6 times 5, which is 30. And then put in my 3 zeros after. Okay, so 30,000 is a pretty good estimate for 1A. Okay. So then, all you're doing on this part, when it says a reasonable estimate for this problem is blank, you're just writing what the estimate is. So you're kind of just writing it again. Okay? So that would be a reasonable estimate for that problem. Okay? Questions on 1A?
No, ma'am.
All right. So 1B, okay, it gets a little more tricky. So again, you choose what you want to round it to, right? I kind of look at this, and the way my brain works, friends, is I just kind of want to get rid of the stuff at the end, right? Like, so personally, Miss Witt would round to the nearest 100. So if I rounded to the nearest 100, I would get 1,100. That's personally what I would do. But if you rounded down to the nearest 1,000, is it wrong? No, not at all. So you could round it to 1,000, and that would be fine. Okay? And then for the second factor, rounding to the nearest 10 would probably make the most sense. Would it round down to 50 or up to 60? 60. 59 is definitely closer to 60 than it is 50, right?
Yeah.
So 60, okay? These should all be squigglies, but anyway. All right, so then I can do 6 times 11, okay, which is 66, okay? And then I can put my 3 zeros in after, right? It was 1, 2, 3. Or 6 times 1, which gives me 6, and then I have 1, 2, 3, 4 zeros. 1, 2, 3, 4. So somewhere in the ballpark of 60,000 to 66,000 is what we're shooting for. If you're somewhere in this range, then you are good.
Oh, yeah.
Okay? So this is the gist of what we're doing. today, okay? I'm going to go forward and kind of explain a little bit. Okay, Brady,
I had a question about the last one.
this one?
Yeah, like
Okay.
we got two different answers. I don't know what one's right.
Okay, sure. So again, you might have different answers, right? Everybody sees like an estimate differently. So having different answers is okay.
But we estimated all the same.
Oh, okay. So personally, I would round this to 6,000. I would do the nearest 1,000. But some of you might have done 5,800, and that's fine. Okay. 25, I would round to 30. But honestly, too, guys, you could keep it at 25, and that would be fine. If that's something that you want to do. But I can multiply 6,000 times 30 a lot more easily than I can multiply this guy, right? So it should be somewhere around 180,000. Somewhere around that. Does that answer your question, Brady?
Yeah, like, so would the bigger answer be more correct?
It depends. I will take either. So the only time that it matters is maybe in a word problem. Like we kind of did that with decimals a little bit, but like that's where you're checking the reasonableness of it, right? So I know we had one. I think we actually had one when you guys were in 4th grade, where it was like, you know, this football stadium has like it can seat this many people.
Oh, yeah,
like
I
yeah.
remember that one.
So like that is kind of where it matters more. Like, oh, it would make more sense to be accurate there so they don't oversell seats, right, for their stadium. That's kind of where more it matters. When we're just doing the math, I'm pretty flexible on it. Okay. All right. So then you're gonna have the homework for homework, but I'm just showing you on the problem set because they are pretty similar. You're kind of doing just the same thing for 2, except now it's thrown in unit form, okay? But 89 tens, right? Remember, it's just like 890, right? 89 tens times 63 tens, which is 630, right? So do you guys remember that from yesterday? If you need to put it in a place value chart, do that, okay? Yeah, Olivia.
When I see like 89 tens, I look at column and I write the column in my head, and I see what is 1 0, so I just add a 0.
Smart, yeah. So to reiterate what she was saying, when she sees 89 tens, she pictures a 10 in her head, so 10, right? And then 89 of those would turn this into like 89 tens, like adding in that last 0 from 10, exactly. 89 copies of 10 is what 89 tens is, right? And so then you're just rounding here and then finding the estimate. So it's the same process, okay, of just rounding and then finding the estimate. So then 89 tens, and then it would be 63 tens, right? So it's really 890 times 630. So I would round those to like 900 times 600. Yeah, and then 9 times 6, refresh my memory. 9 times 6, friends.
Oh, 54.
54, thank you.
54.
And then I see 4 zeros, so 540,000, okay? So you're doing kind of the same thing for 2. Just like, yeah, in a different format. Yeah, I want you, let's see, I should probably be doing this. Can I see you, Leila? Can I see your problem set? Sorry. I'm going to have you just finish the problem set for homework. Okay? Yeah.
What's that? Can you go back to C?
No.
I didn't finish C though.
Nope, you got to finish it. You got to finish it. On your own.
Wait, what do we have to?
Okay?
What do we have to do? Like all of it?
Yeah. Yeah. Except, let's see. Okay, so you're doing, but 1 should pretty much be done. You can finish that on your own though, okay? 2, it's the same thing. Okay? I don't want you to do 3, so you can cross out 3.
Yeah.
So everybody's on the problem set right now. I'm telling you about homework. Cross out 3.
Yeah. Chloe, don't blink. No.
Oh, it does not require voices to do that. Cross out 3. Did everybody cross out 3?
Yeah.
Okay. Moving on to 4. All right, those electric pencil sharpeners are stressing me out. Can you do those at a different time,
Good
please?
thing I
Okay.
don't have
Okay. Well, I'm getting there. Okay. Okay. So 4. Okay, I do want you to do 4. So this is kind of doing it like backwards a little bit. So it gives you the factors, and then you have to find the estimates, but they have to be the estimates that create these numbers. Okay. So you have to figure out what these need to be rounded to get this answer. Okay. So when in doubt, friends, trial and error. Like, try rounding it to the nearest 100 and the nearest 10. And if that doesn't equal that, okay, then maybe we need to try something else, right? Trust me, it's not as hard as it seems, okay? Use your knowledge of place value understanding, too, okay? Use that to help you. And then I do want you to do 5. I guess I have 6, huh?
Did you say cross out 6?
No, I did not. You are going to do 5 and 6. Okay, so the only one you're not doing is 3. Okay? Does everybody understand?
Yeah.
Any questions on what my expectation for homework is?
No.
Okay, beautiful. You kind of have like 2 minutes to get started, and then we're going to go to media. Okay?